Welcome to my Ultimate AP Precalculus Practice Test Volume 2. This version of the test is designed to look just like the AP Precalculus Practice Test 2 found on AP Classroom. Now, it's not the same. I took the problems and I reworked them slightly to make them look different. So there's similarities for sure. They're not exactly the same, but there's just enough difference that I can be like, oh yeah, no, it's not the same problem, but it's pretty close. So let's get started. Consider the functions g and h given by g of x equals 3 to the x and h of x equals 9 to the x plus 1. In the xy plane, what is the x-coordinate of the point of intersection of the graphs of g and h? Well, let's just set these guys equal to each other because that's what it's asking. So I have 3 to the x equals 9 to the x plus 1. Should I get logs? Nah, I need a calculator for that. But you know what I could do? I could change that 9 into 3 squared. Yeah, so I have 3 squared to the x plus 1. And you know what? Let me throw parentheses there, and you'll see why in a second. That's going to equal 3 to the x. Now, there's a rule that says if you have a base to something equals the same base to something, set those somethings equal to each other. I'm not there yet. I have a power to another power. You multiply exponents when that happens. So I'm actually going to distribute 2 to the x plus 1. So 3 to the x equals 3 to the 2x plus 2. Now that I have 3 to the stuff equals 3 to the stuffs equal each other, like so. So I have x equals 2x plus 2. Let's subtract 2x from both sides. Okay, giving me negative x equals positive 2. And if negative x is positive 2, then positive x is negative 2 because multiply by negative 1. And so the answer is B. B for boy, oh boy, was this fun. Problem 1 down. Hope this helps. Problem 2 of Volume 2. The function h is given by h of x equals log base 3 of x. What input value in the domain of h yields an output value of negative 3? All right, so basically it's just saying log base 3 of what gives me negative 3? Well, let's write that in its exponential form. Okay, if you forget the exact formula for exponential form, I use log base b of y equals x, and you can turn that into b to the x equals y. So what that does with this guy, and I know this is x and that's y, don't overthink it. You're going to write out x equals 3 to the negative 3. I just have it written backwards. So let me see. 3 to the negative 3 is 1 over 3 to the third. And 3 to the third is 27. So x is going to equal 1 over 27, which is b. That's problem 2. I hope this helps. The function f is given by f of theta equals a negative 2 cosine theta. What are all the values of theta for theta is between 0, including 0, and 2 pi, but not including that, where f of theta equals negative 1. So basically, f of theta is this, f of theta is that, set them equal to each other. Negative 2 cos theta, I don't need the parentheses there, equals negative 1. Well, let's solve for theta. In order to do that, we have to get rid of negative 2 by doing the inverse operation, divide negative 2, divide negative 2. Cosine theta equals negative 1 over negative 2, positive 1 over 2. And if you're like, sir, Mr. Goat, sir, why did you leave all that space right there? Well, I have to get theta all by itself. And the only way to get theta all by itself is get rid of cosine by inverse cosine both sides. So inverse cosine both sides allows you to cross out the cosine, and now theta equals the inverse cosine of 1 over 2. Now, what does that mean? Well, if you're thinking unit circle thoughts, and that is a perfect circle, as you can clearly see, if you're thinking unit circle thoughts, cos theta is the x value. So what I want is the x value that gives me a half. So if you're thinking, all right, well, x's are positive on the right side, so it's positive over here, positive over here. If I were to think unit circle, the x would be root 3 over 2, root 2 over 2, root 1 over 2. So you give me 1/2 over there, and that's pi over 3. The one directly underneath it is going to give me my other positive 1 over 2, and that is 5 pi over 3. So theta is pi over 3 and 5 pi over 3. Those are my answers, which would be A. Amazing. A. Amazing. So I like to draw the unit circle because for me, I kind of need to have that visual there. It's not necessary if you have stuff memorized, but hey, I have both. So, because I'm a goat or whatever that means. Hope this helps. Which of the following expressions is equivalent to log base 4 of x over y to the 9th? Well, we know rules like this, that if you have like log base b of a plus log base b of b, that you combine those guys through multiplication. We also know that if we have log base b of big A minus log base b of big B, we combine those guys through division, so A over B. And we know that if we have something like n log base b of big A, we can bring that n up here and make that log base b of A to the n. Your teacher probably used different letters, but it's the same idea. This is working backwards. So we have to think of this as, okay, well, what must have happened to get the insides to be a division and an exponent? Well, we must have had subtraction, and we must have had a number in front of it. So what I'm going to do is I'm going to split the division part up first. I'm going to split these guys apart, saying in order to get something divided by something, we subtracted those somethings, the denominator part minus the numerator part. Now, that's not going to be good enough because I look at this and I see some stuff, but it looks like I have to get y all by itself in here. So in order to get y to the 9th, I must have had a coefficient of 9 in order to bring it up here. So I'm going to rewrite this as log base 4 of x minus, bring that 9 down, log base y. 9 log base y. And that's going to be D. Okay, so this is a question where you are being asked to expand, whereas more often than not, when you first learn logs, you're probably asked to condense them into a single logarithm. This is just working backwards. So it's the same rules, just opposite. Hope this helps. Which of the following statements is true about the exponential function h given by h of x, look at this mess, equals 12.512 times 0.717 to the x? All right, so it's talking about increasing, decreasing, concave up, concave down. Let's get a general graph of what this guy looks like. Now, this is in the form y equals a times b to the x. Now, if b is greater than 1, you have yourself exponential growth. And that's what we have. No, it's not what we have. We have a case where b is in between 0 and 1. That is a case of decay. Now, decay, normal decay, is graphed like this. Okay, your numbers get smaller and then it levels out at the x-axis. Now, if we have decay, what does A do? Well, if A is positive, it keeps it looking like that. If A is negative, what it does is it flips things, or better yet, reflects things over the x-axis. In this case, we have a case where A is positive, but B is in between 0 and 1. So we have regular looking decay, so it's going to look something like this. Now, what this looks like is it's decreasing, so not you, not you. And since it's the first half of concave up, it's going to be decreasing and concave up. So our answer for this guy is going to be C. All right, the answers change. Again, if A is negative, it flips it upside down, makes it look like that. That's not what I have. If B was positive, you'd have exponential growth, which looks like that. And if you were to flip that upside down, it would look like that. Okay, so if you need to rewind that and slow it down, Or as I think it was Usher, or maybe it was Ludacris who said, "Take that, rewind it back." Lil Jon got the beat to make the math questions go whack. Remember that song from like 2009? Yeah, with Usher and Ludacris and Lil Jon? The answer is C. Hope this helps. In the xy plane, the graph of a rational function has a hole at x equals -3. The function f also has a slant asymptote with a negative slope. Which of the following could define f of x? So let's take care of step 1 first. If there's a hole at x equals -3, that means this equation must have an x plus 3 and an x plus 3, one in the numerator, one in the denominator, same multiplicity on both. Okay, I'm not looking at, there's no multiplicity, there's no exponents here at all. So you have an x plus 3 in the numerator, you have an x plus 3 in the denominator, you're good so far. You have an x minus 3, x minus 3, x plus 3, but no x plus 3 up here, so B is out of the question. I'm just going to completely cross that out so I can not have to look at it. Negative x, x plus 3, x minus 6, x plus 3, x minus 9. So you have a possibility. X, x minus 3, x minus 1, x minus 3, x minus 1. So there's no x plus 3s here. You're also out of the question. So it's between A and C. So part 1 is we took care of the hole at x equals -3. Now what we have to do is try to figure out what the heck it means by having a negative slant asymptote. Well, a slant asymptote that's negative is going to look like this. Also, if it has a slant asymptote, the degree of the polynomial in the numerator has to be 1 more. Now, looking at both of these options, we have x, 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 and we have x, x, so that still works. And we have x, 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 and x, x, so that's still good. So it's not like that's going to eliminate anything. So let's try to kind of draw a picture of what this could possibly look like, knowing that it's not going to be accurate. So it might look something like this, right? And so what am I looking at for a picture like this that has a negative slant asymptote? Well, if I were to look at the end behavior, that might help me figure out which of these will match. The limit as x approaches -infinity of this guy that I just wrote out, as x approaches -infinity, it's going up. So it's going to approach positive infinity. When I figure out what the limit as x approaches positive infinity of f of x is, my fake problem, it looks like it's going down and to the right, which means it's approaching negative infinity. So what I need to do is take these guys and figure out which one of these has the end behavior where the negative infinity goes to positive infinity and vice versa on that one. So let's take A and test out A. Now, the way you find the end behavior of something that's all factored out is you take the leading coefficients of each factor and multiply them together. X times x times x is x to the third. Take the leading coefficients of all the factors in the denominator and do the same thing. I almost circled 5 there. Be careful. Don't circle 5. You take that and you simplify that and you get x. Now you take the limit as x approaches positive infinity and the limit as x approaches negative infinity of regular x. Now what that looks like is if you're looking at as x approaches positive infinity of x, you're kind of just like, and I'm doing air quotes that you can't see, plugging in infinity to x, which gives you infinity. And if I'm finding the limit as x approaches negative infinity of x, I'm, air quotes again, plugging in negative infinity for x, and that gives you negative infinity. So with A, the limit as x approaches infinity is infinity. That's the opposite of this. So that is a positive slant asymptote. I don't want A. A is not going to do it. Now let me do B and make sure that it works. Make sure I feel comfortable with it. I have negative x times x times x. So that'll give me, where do I have room? X, negative x cubed on top in the numerator, and x times x on the bottom, so x squared on the bottom. That simplifies out to negative x. So if I were to find the limit as x approaches positive infinity of negative x, I would plug infinity into x, and that gives me negative infinity. Okay. Similarly, if I were to take the limit as x approaches negative infinity of negative x, I would get negative negative infinity, which becomes positive infinity. And that's exactly what I want. So C is the answer. Okay, so kind of a difficult problem, kind of a challenging problem, but yeah, we used end behavior to figure it out, and it was kind of fun. I had a lot of fun. I hope you did too. Hope this helps. Oh, look at this problem. You have no clue how long it took me to make this problem. Just for you kids, just to get 30 views and like 3 cents. At time t equals 0, water begins pouring into an empty container at a constant rate. The water pours into the container until it's full. The situation is modeled by the given graph where time in seconds is the independent variable, as you can see here, and the depth of the water in the container in centimeters is the dependent variable here, height of the water. For which of the following containers would the graph be appropriate? So let's see what's going on. Okay, it starts filling up kind of quickly, and then slows down and then picks up the pace again. So if you were to pour this in, okay, this would start filling in faster, 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 and then slow, slow, slow. So A is kind of the opposite of we want. Now, if you're like, well, what do you mean it fills in faster? Since the width gets skinnier, it fills at a faster rate. This says start out slow and then go slower and then go fast again. Okay, so start out, maybe I should have written it out this way. Start out kind of fast, and then go slower and then fast again because it goes from a steep slope to a shallow slope to the same steepness. Okay. B looks promising. It starts out kind of normal, but since it's a wider shape, the rate or the speed at which this fills up starts to slow down. So it goes slower, 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 and then all of a sudden it picks up the speed again because the width of my shape gets skinny again. So it starts normal, gets slower, and then starts picking up the speed. So B seems to do the trick. Now, what C would look like is it's going to fill up at a constant rate. So the graph of that's going to look like this. This is an elephant. I have no clue what the heck that's going to look like, but it certainly isn't going to be a pretty little curve that took me forever to make on Desmos for you kids. So the answer for this one is B, because again, you look at the slopes, it goes kind of fast and then slows down and then slows down and then picks up the speed again. And in order for that to happen, you must have a skinny to wide to skinny again. B is going to be our guy, baby. B for bowl. Well, it's not really, well, it's kind of a bowl, but it's a sphere. Hope this helps. A new car, initially priced at $29,000 and $999, depreciates in value by 15% each year. Depreciates, that means loses its value. And in this case, it loses its value by 8%. Which of the following models a function for the value of the car v of t as a function of time in years? Now, if something's going to lose its value by 8%, what's happening is going to be exponential decay in this case. Now, what this means is you're not going to lose like $3,000 every year. It's not going to go from like $30,000 to $27,000. I'm just pretending it's 10% just to make the numbers easy, to 25. No, it's not going to do that every year. This is not linear. This is exponential. So that gets rid of both of you. These are linear because it's something times t plus or minus something, blah, blah, blah. Okay, it's going to look like this. Now, if you're tempted to say, okay, well, what we'll do is we'll just multiply it by 0.15 because 15% is 0.15. No. If something loses its value by 15%, what you're doing is you're taking 100%, subtracting 15%, and you're now taking 85% of that price. So what we're going to do is we're going to take our initial value, which is that. We're going to multiply it by 80%, which is 0.85, and we're going to repeat the process every t years. So that after 2 years, we do 29,999 times 0.85, whatever that number is, times 0.85 again. You're going to take 85% of the new price after every single year. So that what's going to happen is it might lose like 4,500, I think, is going to be the value the first year, give or take a couple pennies. But then it's going to lose like maybe 4,200 and then maybe like 3,000 something. And it's going to lose its value, but slow down in how much value it loses. It'll never hit zero. It'll still have worth. It'll lose value initially, immediately, right away, but it's going to start losing its value at a slower pace. So the guy that we get is C. D means you're going to take away 85%. That's definitely not what we want to do. Don't buy a car like that. Don't buy a car like that. And speaking of car, the answer is C. And car, last time I checked, starts with C. Hope this helps. Which of the following is not equivalent to cos squared x over 1 minus cos squared x? So we want the lie. So 3 of these are correct. 1 of these is not. Whenever you see a cos squared or a sine squared or a tan squared or anything squared, you want to think those Pythagorean identities. If I have cos squared x, I am thinking the Pythagorean identity that says sine squared x rather, plus cos squared x equals 1. I really don't have that here, but ooh, you know what I do have? If I subtract cos squared x from both sides, sine squared x is the same as 1 minus cos squared pretty looking x. So what I can do is replace that 1 minus cos squared x with sine squared x. I have cos squared x over sine squared x. Okay. So any of these match? No. Oh, but you know what? Cos squared x over sine squared x is cos squared, or cos x over sine x is cotangent. So cos squared x over sine squared x is cotangent squared x. So you are true. So I like you. I'm going to keep you. Ooh, cos squared x is the same as cos x times cos x, and sine squared x is the same as sine x sine x. So you are a true statement. And let me see. Oh, if I were to move cosine squared x down, I would have secant squared x on the bottom. And if I were to move sine squared x up, I would have cosine squared or cosecant squared x on the top, which makes you work. Oh, tangent. You little rascal, it's not tan squared x. And the moment I got the fact that it was cotangent squared x as the answer, that automatically gets me to the point where I can say it definitely can't be B. So B is going to be my answer. Remember, I want the one that is not equal to that. And B is the one that's not equal. Wasn't that neat? Hope this helps. The location of point X in polar coordinates r theta is -3 pi over 6. What is the location of point X in rectangular coordinates xy? You know very well that rectangular coordinates, if viewed from a trigonometric point of view, is going to be r cos theta, r sine theta. Well, you're my r, and you're my theta. So let's do some simplifying, shall we? You're going to be -3 cosine pi over 6, and you're going to be -3 sine pi over 6. -3 times cosine pi over 6 is going to be -3 times the x value that you have if you go to pi over 6 on the unit circle. So if you need to draw the unit circle and say, all right, pi over 6, that's the first one. So the x value of that first one is going to be √3 over 2. So it's going to be √3 over 2. Similarly, the sine value of pi over 6 is going to be the y value, which is going to be 1/2 for that first guy right there. So -3 times 1/2. -3 times √3 over 2 is going to be -3 √3 over 2. You know what? Let me write it out the way that they want me to write it out just to be a little more consistent. -3 in the numerator, root 3 over 2. You're going to be -3 over 2. B is going to be my guy. All right, so again, if you have this memorized, drawing that out's not necessary, but this is me converting polar into rectangular by going back to the old trig version of what it means to be rectangular. And so there you have it. Hope this helps. Problemo once a function and two coordinates are displayed on the graph. There's my function, there's my coordinates. That looks exponential to me. What is the y value of the function when the x value is -1? Well, this is exponential for sure. And so what I'm going to do is I'm going to create an xy table by drawing that perfectly straight line and just kind of go backwards. So I have 3/8 and I have 4/16. So close to John 3:16, my favorite Bible verse. It looks like going this way, you multiply by 2. So going backwards, you divide by 2. Makes sense. So you would be 2, 4, because 8 divided by 2 is 4. 1, 2, because 4 divided by 2 is 2. 0, 1, because of divided by 2. And here we are at -1. 1 divided by 2 is +1/2. So pretty simple problem. You just need to recognize that it's exponential. And with exponentials, you multiply this number by the same number every time. So working backwards is the inverse of multiplication. Division. Hope this helps. The table gives values for a function g at selected values of x. Which of the following statements is true? So it looks like it wants us to talk about linear, quadratic, linear, quadratic. So this is what I have to do. I have to make sure that the x values go up by the same number every time, and they go up by 2. Now, usually when they see these, they go up by 1. But in this case, with this problem, I had them go up by 2 because just like 2 chains, I'm different. Now, what we're looking for over here is to see the first order of rates of change. That gives us whether or not this is linear. If the rate of change is constant throughout, it's a linear function. So what do we do to get from 8 to 9 to 8 to 5 to 0? Well, I'll tell you one thing. It ain't linear. We add 1, we subtract 1. We subtract 3, we subtract 5. It's not linear. So it's not linear, which means no to U and no to U, A and C are not an option. Now, to test to see if it's quadratic, we need to see if the rate of change is constant. So what happens here? Well, from 1 to -1, you subtract 2. And from -1 to -3, you subtract 2. And from -3 to -5, you subtract 2. So this is quadratic. This is quadratic. And it's quadratic because the second differences of the output values over equal interval input values are constant. Now, it's D, but if you're looking at two phrases that you don't like, here's phrase number 1. Equal interval input values. That is these guys. Since these guys change the same exact amount of numbers, or it's added to every single time, that is the definition of equal interval input values. Okay? And that's constant. Thing number 2 that we care about is the successive second differences of the output values. Some problems might word it as the rates of change of the rate of change or the second rate of change. Either way, it's going to be this guy because it's the second differences and not the first. The first differences would make it linear. So the answer is D, and hopefully I explained these well enough with minor stuttering. For, again, equal length, I can never say this correct. Equal interval input value lengths is very difficult to say. Say it twice, 5 times. I dare you. I'll give you a second. See, I told you couldn't do it. Hope this helps. The function f is given by f of n equals -2 log base 3 of n. And the function g is given by g of n equals 3 to the nth. If the function h is given by f of g of n, which of the following expressions for h of n, which of the following is an expression for h of n for n of 0? So I prefer, n is greater than 0, I prefer to write this out as f of g of n. Okay, that's how I like to do it. And if you're like, no, I prefer the fog looking thing, well then good for you. What you do with this is you start out with f, and f is -2 log base 3 of n. You write out all of f and leave a nice big blank space for where n is, like so. You replace that n with whatever g of n is, and g of n is 3 to the nth power. Now, there's two ways that you can look at this. And I'm going to do both because why not? Way number one, and let me rewrite it out. Way number one that you can look at this is you could say, oh, wait a minute. Log base 3 of 3 to the n allows the log base 3 and the 3 to cancel each other out and drops the n down, so we have -2n. That's one way of looking at it, check. Another way of looking at it is you could say, I can bring that -2 up here, and so I have log base 3 of 3 to the n to the second power, negative second power. Multiply these two, and that gives you log base 3 of 3 to the -2n. Just like we had over here, log base 3 of 3 cancels out, and you're left with -2n. Either way, you get -2n. Which method is easier? I don't know. But we did it in two different ways, and that's very important in math land, pre-calculus math land. They want you to look at things in like 4 different ways, and I did 2 of them. So there you have it. Hope this helps. This is the binomial theorem. The binomial theorem is trash. But what we are being asked to do is find the coefficient of the third term when b of x is expanded and written in standard form. So I have to do the binomial theorem. So let me do the whole thing, even though it's a pain in the butt. First, you need Pascal's triangle. Okay, Pascal's triangle starts with the number 1 over here, and the number 1 exists when you have a degree of 0. Okay, then you go to 1, 1. That's a degree of 1. Then you go 1, 2, 1, and the pattern here is any number that is underneath and in between is the sum of the numbers above. That's degree 2. We are going to work our way to degree 4. Okay, so we have 1, 3, 3, 1. That's degree 3. And last but not least, degree 4 is going to be 1, 4, 6, 4, 1. All right, I'll explain what those guys are in a second. Now, what you do when you do Pascal's triangle and the binomial theorem is you take this guy and pretend it's A and B. So you have A plus B to the nth. What you do with a plus b to the nth, and in this case n is 4, is you write out these numbers, and I'm going to spread them out. 4, 1, not 4, oh my gosh, just 1, silly me. I looked at the degree 4 and got it roped in. 1, 4, 6, 4, 1. You start out with the first coefficient, the first term, and you say a to the 4th and work your way down. A to the 3rd, a to the 2nd, a to the 1st, no more a. Then you take b, do b to the 4th all the way to the right, and you work your way down from the right, like so. That's 1. When I said like so, it threw me off. No b. Plus sign, plus sign, plus sign, plus sign. Now, all I have to do here is find out the third term. This is already written in standard form, and it's going to be the coefficient of the third term, not even the whole thing, but I am going to do the whole thing just for practice. We called A x, so A is x, and we called B -4, so now I have to plug those in. So I have 1 times x to the 4th plus 4 times x to the 3rd times -4 plus 6 times x squared, -4 squared, plus 4 times x to the 1st, -4 to the 3rd, plus 1 times -4 to the 4th. Last but not least, let's simplify this guy out. X to the 4th, 4 times -4 is -16, x to the 3rd. 6 times -4 squared. -4 squared is 16, and 6 times 16 is 96. So positive 96, which gives us our answer. X squared. Negative 4 times negative 4 times negative 4 is negative 64. And 4 times negative 64 is negative 256. Drop down the X. And then again, negative 4 times negative 4 times negative 4 times negative 4 is the positive 256. So that's binomial. You go one more degree and then you add more numbers. You go one more degree and then you add more numbers. It's not a pleasant process at all, and you're not going to see it that much, unfortunately, on these AP exams. So maybe you'll see it, maybe you won't. But if you do, that's how you do it. So hope it helps. Which sinusoidal function is represented in the graph below? All right, so I'm going to write out, I have sines and cosines. I'm going to write out the basic version where you have y equals a. I'll write out trig, and trig could represent sine or cosine here because that's clearly what they want. Parentheses b to the x minus c, parentheses, parentheses, plus d. The first thing that you should always start out with when trying to figure out an equation is your midline. At least that's one of the first things you should figure out. Okay, where do I have a horizontal line cutting this guy in half? Well, it looks like that happens at -1. So this is going to be -1, which eliminates C. The first thing you can do now that you have your midline is find your amplitude pretty easy, and that's by going from your midline to the maximum value and seeing what the distance of that is. So 1 minus -1 gives me a distance of 2. My amplitude is 2. Now, before I cross A and B out, here's the thing. In any of these or in both of these situations, I have no horizontal translation. This guy represents a shift to the left or to the right. I don't have that in any of my options, so I'm not going to worry about C. So basically what's happening here is I'm starting right there and working my way down. Now sine, regular sine, when graphed, looks like this. This guy is the flipped version of it where it looks like that. So if this is regular sine, then this is going to be negative sine. So the answer's got to be A. Now let me make sure that I'm good. Let me make sure that I'm good and make sure that the frequency is pi. Now B stands for the frequency. Now what the frequency gets you is if you have the frequency of pi, the period is going to be 2 pi over the frequency. So in this case, my period is 2. So if I were to look at, I don't know, an obvious spot like here and go 2 spaces later, it looks like the period is 2. So everything seems to match quite nicely. Again, negative sine, period of 2, which makes a frequency of pi. It goes down 1, giving the midline of -1. So yeah, the answer is going to be A. Hope this helps. The graph below models a sinusoidal function with points A, B, C, and D representing coordinates on the curve. One of A, B, C, or D represents an inflection point, probably U, because it's right in the middle. And one also represents a relative maximum, probably U, because, Rat Monster from, what's it called? What are they 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 called? They sing Butter. They sing BTS. Anyway, relative maximum. Which of the 4 locations would represent the largest instantaneous rate of change? What the heck does instantaneous rate of change mean? That means slope at a point. So the best way to describe this is make believe that you're riding on a roller coaster, and at which one of these points are you going to be the steepest? Okay, the steepest positive instantaneous rate of change. Well, if this was a roller coaster, right now you're going down, and you're leveling off. So maybe right here your slope would be almost 0 or 0. Now we're moving our way back, and now we're pretty steep. That looks like it's kind of pretty steep, but this is even steeper, because it's the inflection point. and the inflection point is going to have the steepest. How do I know that? Well, concave up, okay, means it has, like right here, in this case, it's decreasing, but this is increasing at an increasing rate, which means the rate, also known as slope, is increasing up until this very moment right here where it hits its peak increase. Now it starts decreasing. So what's going to happen is if we are riding a roller coaster, we are at its maximum slope here, and then it starts leveling out and has a zero here. So the maximum slope is going to happen at an inflection point. Okay, so the answer in this case is going to be B. Now, if we were going to be asked the least, the least is going to be where it's decreasing and closest to a maximum or a minimum. But that's not what we're asked here. We're asking for the steepness, and the steepness is the steepest at an inflection point. Kind of tricky problem, but I hope I explained it well enough with the whole roller coaster thing, and I hope this helps. 4 polar coordinates are given by C, A, T, and S. It's an interesting choice of letters. Who made that problem? Which statement is false? All right, so 4 coordinates, some positive, some negatives. Let's understand what that means. A polar coordinate is given to you by a R, which pretty much stands for radius, and an angle, which is your direction counterclockwise from the positive x-axis. So if you were to ask something like C, and we'll go over it slowly just in case you're not used to these problems, you view this from a viewpoint of a unit circle. Now, all of the radii, all of these guys are some form of 2. So I'm going to draw a terrible circle, as you can see. But the radius for all of this, the radius of this whole circle is going to be 2. So we're going to pretend that that point right there is 2, 0. Now, if I were to graph 2, what I do is I make sure that I know that the length of my line that I draw, or the point rather, is going to be 2 units away from the center, also called the pole. Now, this guy gives me a direction going in the counterclockwise motion from the positive x-axis. So you're basically going this way starting here. So you're 0, like a normal unit circle, pi over 2, pi 3 pi over 2. So without being perfect, if I'm going to go in the direction of pi over 3 and put a dot 2 units away from the pole, I'm literally going to have a point right around here. I'll call you C. Okay, so that's where C is going to be. Now, if I were looking at these, and let me clear some of this mess up. If I were looking at these and thinking negative radius, what does that mean? Negative R. Well, let's figure out what pi over 6 is first. Pi over 6 is like way down here. So I'm going to go all the way counterclockwise to way down here. So I'm going counterclockwise way over here. Okay, but since this is negative 2, I'm not going to put a dot here. I'm going to go in the opposite direction. So my dot has me going all the way around here, but since it's going to be a negative 2, I'm going to put my dot right there. Okay, so you're going to be A. Again, normally you would go in this direction, but since it's negative 2, you go in the opposite direction, which gives me that A right there. I'll leave those arrows just in case I need them. Now, the same thing's going to happen again and again. Okay, we go to negative pi over 4. Now, negative pi over 4 has me going clockwise. So regular pi over 4 would be halfway to pi over 2. So negative pi over 4 would be negative halfway to negative pi over 2, or basically right here. So you're now here, but again, we have a negative distance. So instead of putting my dot on 2 over here, I'm going to put my dot right here in the negative distance. So T is kind of next to A. S, I'm sure by now you're kind of getting the point. If you see a little thing pop up, that's me getting a different color. We're going with orange. Pi pi or 3 pi over 4 is right around here, but it's negative. So 3 pi over 4 lives here, but a negative distance puts me over there. That's my S. So let's see what they're asking and circle the one that's the lie. Point C exists in quadrant 1. That's true because 2 represents a positive distance. That's true from the pole at the angle pi over 3 when rotated counterclockwise from the positive x-axis here. Don't see anything wrong with that. So A is not going to be the option we want because it's actually a true statement. Point A exists in quadrant 2. So far, so good, because negative 2 represents a distance in the opposite direction from the pole at angle 11 pi over 6 when rotated counterclockwise from the positive x-axis. Again, no lies detected. B is not going to be our answer. B is a true statement. The point T exists in quadrant 4 because negative 2, T is in quadrant 2. So we have our lie already. So that's the guy we want. But let's keep going because negative 2 represents a distance in the opposite direction from the pole at angle negative pi over 4 when rotated counterclockwise. So there's error number 1. There's error number 2. So that's why C is wrong. Because if you're going in the negative direction, you're rotating it clockwise. Either way, we could have stopped right here. S is in quadrant 4 because negative 2 represents a negative distance from the pole at the angle 3 pi over counterclockwise. So a true statement. C is definitely the lie. So C is the one that we're going to circle. So I did a lot here, but that's okay. I just wanted to explain things thoroughly because, you know, this is towards the end of Unit 3 and you never know how much polar coordinate stuff you're given. Plus, there's always, when it's written out this much, you really need to be thorough, and I just wanted to be thorough. So I hope this helps. Michael and Dwight were working on a problem where they were asked to write a sinusoidal equation representing the height of a Ferris wheel with a radius of 21 meters, rotating at a rate of 1 revolution per 100 seconds. What do we have? We have a circular object with radius of 21. So whenever you're dealing with sinusoidal stuff, right, and you're given a circle and you're given a radius, automatically that's probably going to be your amplitude. And that is going to be our amplitude. I'm just giving you a heads up. What else do we know? Well, if it rotates once every 100 seconds, then that's going to be our period. Okay, let's keep on going. It was assumed that the ride begins when the rider of the Ferris wheel is at the bottom of the ride. So Dwight wrote out the equation h of t equals negative 21 cosine pi over 50 t plus 21. Now let's see what that looks like. Okay, let's see the picture that Dwight came up with. Let's see if there's any issues or whatever. All right, so midline 21. Okay. Negative 21 cosine gives us that amplitude of 21. So we're up here at 42. We're down here at 0. Negative cosine is actually right here. And if you're like, well, why not sine or something like that? Well, let's think it out. Cosine looks like this, right? But we're starting at the bottom, like Drake, which starts down here and looks like that. Now, if we shift that up a bunch, if we shift that up the amplitude, we are now starting out down here, and the height's going to go up, and it's going to come down and repeat itself at 100. So the picture, I mean, given what we have, Dwight looks like he did a pretty decent job. All right, now pi over 50, if you're wondering, well, where did that come from? This is a cosine function, so that's our frequency. And the way you get frequency is you do 2 pi over the period, which is 100, and that simplifies out to pi over 50, like so. Okay, so everything seems fine. Everything seems good. Oh, but Michael swoops in and reminds Dwight that the bottom of the ride actually is 2 meters off the ground. So 2 meters off the ground is going to be up 1, 2, making the midline 23, the bottom 2, and the bottom 44. Now, how does that change this function? Just the midline. That's it. So all we have to do is just change that to 23. Which, should I give the same answer twice? I did. Ugh. So I think I meant to put 22 here, but I made it 23. I was thinking Taylor Swift thoughts. but I accidentally made them both 23. So, you get the idea. Even though it's a poorly written problem, you get the idea. But yeah, that's your guy, Michael and Dwight. That's what she said, right? It's the show, The Office. Hope this helps. In the xy plane, two different angles, alpha, ooh, are we making a problem about me? And beta are in standard position and share a terminal ray. What does that mean? Well, if you were to graph something, okay, here's your regular thing, your regular initial ray, and then your terminal ray is going to show up like this. Both of these guys will look like this, have the same exact picture. So, whatever this is, if I have another one, it's because you added 2 pi or subtracted 2 pi or added 4 pi or whatever. Okay, you spun around again and got the same exact thing. Or maybe you spun around in the opposite direction, which is what minus 2 pi would be. So, based on this information, which the following gives possible values for alpha and beta. So they're going to give you two equations. And are these, not two equations, but two radians. And you have to figure out, are these guys the same ones? Well, this is negative 3/4 pi, which lives over here. Is me adding 2 pi going to get me 3 pi over 4? No, then A is not the option. Is me adding 2 pi going to give me that? Well, we're actually subtracting, so is me subtracting 2 pi going to give me negative pi over 4? Nope, negative pi over 4 is if you subtract 3/4 pi by regular pi. So that's just spinning it in the opposite direction like that. So that's no good. Pi and 2 pi, no. I mean, here's pi, here's 2 pi. They're definitely not the same ones. So it's got to be u. So if I'm going from a positive to a negative, it must be because I took 11 pi over 6, subtracted 2 pi, which looks sloppy. So I'll turn 2 pi into 12 pi over 6 to get negative 1 pi over 6, or just negative pi over 6. So yeah, 19 is a problem. That's basically saying, hey, which of these guys are exactly the same? Add 2 pi, subtract 2 pi, blah, 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 blah. D is going to be your answer. Okay, pretty standard. Hope this helps. In the xy plane, the function h is given by h of x equals 4 to the x plus 9, and it's a horizontal translation of the exponential function f. Well, we could see that because you have positive 9 trapped inside the x parentheses, which means we actually make our guy move it left, a negative horizontal translation. So there it is. So yeah, there's the regular function. By adding 9 inside the parentheses, we move left 9. Cool. Which of the following is equivalent for h of x? That expresses h as a vertical dilation. All right, so a vertical dilation is not the same as a translation. So if you're thinking, oh, they want us to add or subtract. No. That's translation. When you do a vertical dilation, you take your f of x and you just multiply some number to it. Okay, so if our f of x is 4 of x, you're just going to take a number, and it looks like they want us to use 2 here, and multiply 2 to it. So b is going to be our guy. Now, that's a vertical dilation. If you're thinking, well, what about a horizontal dilation? The horizontal dilation would look like this. So now you'd be taking 4 to the 2x, okay, which is an option that I probably should have given, but I gave you A, which is kind of close. But yeah, that's what we have here. This represents a vertical dilation, not to be confused with a horizontal dilation, not to be confused with a vertical translation, which is when you would add 2 to 4 of x, 4 to the x. So yeah, transformation stuff is kind of a mess. But yeah, we did it, and boy, did I have fun. Hope this helps. The table shows a portion of function h of x that is either concave up or concave down, but not both. Describe the graph of the function on the interval 1 to 5. So here we go. We have our graph between 1 to 5. And it's telling us right now that it's going to be concave up or concave down. So what I'm going to do is I'm going to find the rate of change, which gives us our linear change. And so this is going to help us figure out what the average rate of change is going to be. So linear is also like when you're finding the linear stuff here, you're finding the regular rate of change. So what are we doing here? Well, we are going from -3 to -10. By the way, these all go up by 1. So that makes it the equal length input value intervals being the same. Okay. These go up by, what am I doing? Adding 3, you're adding 5, you're adding 7, and you're adding 9. So what we have is these go up by the same amount of numbers. These go up by different numbers, but the numbers as you go up are increasing. So we would say that the rate of change is increasing, making it concave up. Okay, so the graph of h is concave down? Nope. The graph of h is concave up because the function is increasing and the average rate of change over equal length input value intervals is increasing. Yup. The graph of h is concave down? Nope. The graph of h is concave up because the function is increasing and the average rate of change over equal length input value intervals is decreasing. Nope. So whenever your rate of change is increasing, you're looking at concave up. Okay, simple as that. Boy, was that fun. Hope this helps. Which equation below represents P of t equals 3 sine 2t minus 4, translated 4 or pi over 4 units left? All right, well, I'm going to compare this to like the regular old sinusoidal thing. So we have sine, we have parentheses b. In this case, it's t, so t minus e, close it, minus 4. Well, what do we have? We have a is 3, so we have 3 already. We have sine. What I'm going to do is I'm going to separate the t and the 2 with that parentheses. So we're basically pulling this out. Now that gives us frequency. Okay. We don't know what c is, although we do, but we don't know what c is. But what this does is when it's worded out like this, okay, when you are going to translate horizontally, you have to include these parentheses here if you have a coefficient in front of your variable. We do. We can't just say something like 2t blah, 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 blah something because you're not doing it right. You need those parentheses there. So if I'm translating left, that means c is negative pi over 4. So if c is negative pi over 4, we have a negative pi over 4, giving us 3 sine parentheses 2t plus pi over 4, close it, minus 4. And c is the one that gives us that parentheses, the doubled up parentheses, and the positive. So again, things kind of seem backwards when you're inside this parentheses with your variable. And why would that change here? So make sure you write it all out. Make sure you include the parentheses. Make sure you do opposite of what it seems like it should be whenever you're dealing with horizontal translations. And you'll just get it right, baby. Hope this helps. You ready for a stupid problem? The function p models the population of a city in thousands of people as a function of time t. In years, t's got to be positive because, you know, real life. The function r models water consumption in gallons per day as a function of population size. Let w be the composition function defined by w of t equals r of p of t. Which of the following statements is true about w? Now, before I go on further, this is a problem that looks very similar to an actual AP Precalculus, legit AP test, AP Precalc, AP test problem, practice problem test. Okay, so it looks very similar. And when you're finding w of t, it's still a function of time. So that's it. I mean, it's a strange problem. Like, you're not given anything to simplify. You're not given any math to do. You're just saying, okay, well, it's still a function of time because it's w of t. So, yeah, I mean, that's it. That's this problem. Pretty stupid, but, you know, hope this helps. The arc length of arc QP of the circle below is 11. By the way, arc length is given by the formula arc length equals radius times central angle. The circle has a radius of 8. Which of the following would give the y value of point P? All right, well, it tells us that the arc length, which is given to us by doing radius times the central angle, is going to be 11. So arc length is 11. That's going to equal a radius of 8 times the central of angle of theta, which we don't know. So theta is 11 over 8. Okay. Theta is 11 over 8. Well, that's nice. We have the theta part. Now, what we have to do is we have to give the y value of point P. Since we have a radius of 8, we are not just doing, regular cos theta, regular sine theta. This is not the unit circle. This has a radius of 8, so we have to throw the r there. Now, the y value is going to be sine. So we need to find r sine theta. R is 8. Sine is sine. Theta is 11 over 8. Our answer is C. Okay, so kind of a different problem, kind of a unique problem. You have to remember what the arc length is, which not everybody does, but there you have it. It's a radius times central angle, and then the rest is up to you. Power is yours. Captain Planet. Hope this helps. Which of the following equations represents all vertical asymptotes of f of x equals 6 secant x minus pi over 2? Vertical asymptotes exists when the denominator of a fraction equals 0. So it would make sense to me that maybe I should take secant and change it. So I could draw this out or write this out as f of x equals 6 times 1 over cosine, because secant is 1 over cosine, x minus pi over 2. Again, what gets me vertical asymptotes? Whenever the denominator is undefined. So I want to find out when cos x minus pi over 2 equals 0. 6 has no effect. 6 just gives me height. It doesn't tell me anything about the vertical asymptotes. So if I have cosine of x minus pi over 2 equals 0, and I want to get x all by itself. Since I have cosine of stuff, right away I can inverse cosine both sides. So I'm going to inverse cosine both sides, bada bing, and that leaves me with x minus pi over 2 equals whatever the inverse cosine of 0 is. So cosine is x, so what degrees give me an x value of 0? 2 of them, pi over 2 and 3 pi over 2. So I'm going to solve these for two different equations. I have x minus pi over 2 equals my one option, pi over 2. And I have x minus pi over 2 equals my other option, 3 pi over 2. Add pi over 2, add pi over 2, and a half a pi plus a half a pi gives me a whole pi. Sounds delicious. That's one option. My other option is to do the same exact process, add pi over 2, and 3 pi over 2 plus pi over 2 is going to be 4 pi over 2, which is 2 pi. Now here, it's asking me to find all of them. So technically I have pi plus 2k, where k is any integer, and 2 pi plus 2k, which k is any integer, because you always add 2 k's to it. And if you're wondering, I'm sorry, 2 pi k, oh boy, would that change everything. Now, what that means is I have options like pi, and 2 pi, and 3 pi, and 4 pi, and so on, so on, so on. So basically, how can I write that out? Well, if I wanted to, I could take 2 pi, and just keep adding a pi, add a pi, add a pi, add a pi, add a pi. Now, if you're like, well, what about pi? Well, k is any integer, which means it could be -1, -2, -3. So all of these will work. So A is going to be my guy because all of these are only focused on adding 2 pi instead of regular pi. So, we had to word the answer differently than maybe what we're used to. But the numbers are convenient enough where we can make A our selection. Hope this helps. Which of the following statements about f of x equals x squared minus 9 in the numerator, x minus 3 in parentheses squared times x plus 5 in the denominator is false? They want the lie. So it's like 3 truths and a lie, the game that you played in high school. I didn't because I didn't have friends. This is what we're looking at. We're looking at a rational function. The bottom is factor, the denominator is factor, the top is not. So let's factor out the numerator. X squared minus 9 is a difference of squares. X squared minus 3 squared. So you become x plus 3, x minus 3, like so. The denominator does not change. X minus 3 in parentheses squared, x plus 5. Okay. Now, again, we're looking at, just briefly zooming through this, we're looking at magic words like vertical asymptotes and zeros and wholes. So what we need to do is we need to pretend that each of these factors are set equal to 0 and figure out their magic numbers. For example, if x plus 3 was equal to 0, you subtract 3 and negative 3 is your magic number. Positive 3 is your magic number. Positive 3 is your magic number. Negative 5 is your magic number. Now, when we're dealing with rational functions, we're dealing with vertical asymptotes, wholes, and zeros. Up here in the numerator, we have x plus 3 in parentheses and nothing else like it. If you have a factor that doesn't repeat itself in the numerator, you have yourself a 0, and that's what negative 3 is going to be. And what we also have in the numerator is x minus 3. In the denominator, we have 2 of those. So if the multiplicity of a factor in the denominator is greater than the numerator, the denominator is more powerful and you have yourself a vertical asymptote. If they were exactly the same, you'd have a whole. If they were greater in the numerator, you'd have a whole at the x-axis. But that's what we have, a vertical asymptote here. X plus 5 in the denominator, minus 5 is your magic number. That's the only thing that's there. You have a second vertical asymptote. Okay, so let's take a look at our options. F of x has a vertical asymptote at negative 5 because there's a factor of x plus 5 in the denominator and no such factor in the numerator. That is true, so that's not what we want. We are not going to select that. Okay. F of x has a 0 at x equals negative 3 because there is a factor of x plus 3 in the numerator and no such factor in the denominator. That is also true, so that's not the one that we want. F of x has a vertical asymptote at x equals 3 because the multiplicity of the x minus 3 is lower in the numerator than the multiplicity of x minus 3 in the denominator. That is also true. Okay, so be careful with the wording, but it does say multiplicity of the factor x minus 3, so you have a multiplicity of 1, is lower in the numerator than the multiplicity of x minus 3 in the denominator. True statement. F of x has 2 zeros because the numerator x squared minus 9 can be factored. I mean, yeah, it can be factored to that, but this is not a 0 because it's negated by that. So D is the lie. D is the lie, which is funny because D is devil, and the devil is a liar. I hope this helps. The residual plot is the result of a model created using linear regression on a graphing calculator. A and B also represent data points. Which statement is true? All right, so if you don't understand linear models or residual plots, let me kind of show you what this is. This is supposed to represent a line of best fit. That is supposed to represent a line of best fit. Okay, usually if I have a line of best fit, I have a couple dots living above, maybe 1 or 2 on, a couple dots living below, and we would say this line of best fit represents, a line that tells us where all these dots are headed. These dots are going to continue heading up and to the right. Well, if we take that blue line and drop it down that way and remove all these dots so that, not remove them, but change where these dots are so that now they're still kind of like hovering over these dots here. I'm trying to make the same dots. We would say, oh, okay, so like these dots live above the line, so those dots live above the line. These 2 dots live on the line, so those do too. Those 5 dots live below the line, blah, 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 blah. So a residual plot, when you have no obvious pattern, like we have here in this blue line, when the dots show no pattern, we have a good model, like I was in college. Hand model. Now, when we look at this, see how these dots go up and almost show like a negative quadratic, a negative parabola? Well, this is a pattern. This is a clear pattern. So this would be a bad model, like I was 1 year ago when I modeled for swim trunks. So, all right, so that's one thing that we know. It's a bad model. Great. What else? We have an A living up here above the residual plot, which means like maybe you would be like an A. Somewhere over here above the line would be an A. So we would call a point like A an overestimate of the actual prediction, an overestimate. Since B lives below, we would call it an underestimate. And looking at this without looking at the multiple choices that I created on my own, looks like we have enough information to hopefully get something. So a linear model is appropriate for the data. Well, we said that this is a bad model because we see a clear pattern happening on the residual plot. So is a linear model appropriate for the data? Absolutely not. So that is not a true statement. The original data represents a negative correlation. Well, negative correlations are dots that go down and to the right following a linear pattern. We already said that linear is no good. So if linear is no good, how can it be a negative correlation? Well, I'll answer that for you. It can't. The point A is an overestimate of the model. Well, here's A, here's the model. A is over the line, so A is an overestimate. That is a true statement, C. Now, if you're looking at this and saying, whoa, 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 I see that word right there. How can the answer be C? Watch the words. The model produces an underestimate of the point B. Our words are backwards. The model is up here. B is down there. So it's not saying B is an underestimate of the model. It's saying the model is an underestimate of B. It's backwards. The model lives above B. So the model overestimates B, not underestimates B. So since the wording is strange, we have to be extra, extra, extra careful. All right? So I don't like it, but you have no choice. I'm sorry. Hope this helps. The graph below shows the polar equation r of theta equals 2 cos 3 theta graphed on the interval AB. What are the values of A and B? All right, so obviously I don't have the whole picture. If you have your pictures memorized, you know that this is going to be, since that's odd, you're going to have a 3-petal, as I think a D, a 3-petal rose-looking thing that goes out to 2. And since this is cosine, it's, and I'm not even going to attempt to try to draw this, it's going to look like that. Oh, perfect picture. But that's not what I have. I have what appears to be like 1.5 petals. So I have to kind of deal with that. So what I'm going to do is I'm going to graph what 2 cos 3 theta looks like on a rectangular plane. All right. So if it's 2 and cos, it starts at 2, bottoms out at -2, no midline to worry about. This is just a regular 3 rows. It's going to go, let me get a different color. It's going to go down and up, down and up, down and up, and have 3 cycles completed, so at 2 pi. Now, how do I know that? The frequency is 3. So whenever you're given the frequency, that tells you how many times it's going to repeat once it hits 2 pi. If you're like, I don't like looking at that, I'd rather find the period, then fine. The period is going to be 2 pi over the frequency, and you can figure it out that way. So some magic numbers to look at, okay? It repeats every 2 pi, and it repeats 3 times. So halfway through at regular pi, we're at -2 here, okay? Halfway in between that, we hit the 0 axis, so that's pi over 2. And then we hit 0 here at 3 pi over 2. So, you know, just in case you need the numbers there, 0, pi over 2, 3 pi over 2. Nope, that's pi. Hee hee. Hee hee hee. It's my Michael Jackson impression. And this is 3 pi over 2 over here. Now, as you can see, at 0, we're supposed to start at 2. And you might be like, oh, hooray, that's what we have. At 0, we do start at 2. However, this is having us live in positive R land and approaching 0. So it actually starts out going like this. Okay, now it hits 0, hits negative land, and hits 0 again. Okay, so like that. Now I know the picture's not really good at all, but what we know is now where we need to be where we need to be. See, this part wasn't on the graph, but here we are at pi over 2, 0. So there's 0 at pi over 2, and at pi over 2, we're living in positive land. Sorry, I hit a button. We live at positive land and then come around. We are where we need to be. Okay, at somewhere here, we hit negative land and stop being negative. So as we go from pi over 2, we hit negative land and have a negative distance, which goes the opposite direction of what's going on over here. So what we have is a graph on pi over 2 to pi. I'm not even going to bother marking up the rest because clearly I can't draw any of this stuff. But tricky problem. Not a fan of it. Not a fan of it, which is funny because it kind of looks like a fan. But I personally am not a fan of it. But, you know, hope this helps. Hey, hey, hey.